All right, this question was sent to me by a Year 12 Methods student. So we want to find d dx of x sine of 3x and hence evaluate the definite integral from 0 to pi on 6 of x cos 3x. Okay. So this one is kind of a poor man's integration by parts, which will make sense to some of you, but if you haven't heard of integration by parts, that's fine. We'll go through this methods style. So this is a Year 12 Methods VCE question. All right, so the first thing we need to do is find d dx of x sine 3x. So d dx of x sine of 3x. All right, we're going to use the product rule for this because we've got a product of x and sine 3x. So let's let u equal x. Let's let v equal sine 3x. Derivative of x, it's not x, it is 1. The derivative of v is 3 cos 3x. Therefore, the derivative of x sine 3x is the product of those two, 3x cos of 3x, plus the product of these two. Okay. Now we are happy with this because our x cos 3x has appeared, so we can use this fact. Let's do some rearranging. So let's rearrange this so we have x cos 3x as the subject of the equation. So we have x cos 3x will be equal to 1/3 of d dx of x sine 3x minus sine 3x. So I subtracted this from both sides to get this, and then I divided by 3. That's why that third is out the front. Okay. Now let's look at the indefinite integral. Okay, so what is our indefinite integral here? So if I take this, I will have the, let's do it with a pen, I'll have the indefinite integral of x cos 3x, and that's going to be equal to 1/3 times the integral of d dx x sine 3x minus sine 3x dx. All right, we can separate this integral quite nicely, so we can have 1/3 the integral of d dx of x sine 3x dx minus 1/3 the integral of sine of 3x dx. Now what do we notice here? I've got the integral of the derivative of x sine 3x. So they will cancel. So this derivative cancels out these integrals. So I'm left here with 1/3 x sine 3x. Now with this guy, I look at my formula sheet, I know how to anti-differentiate sine, so this becomes negative 1 on 9 cosine 3x. Okay. We're not going to worry about the plus c here. It's correct to write it, but you'll notice that because we're looking for a definite integral, the plus c will cancel, so we don't have to worry about it here. We weren't asked to find the indefinite integral, we were asked to evaluate a definite integral. So in that context, you don't need that plus c. All right. So let's now go through our definite integral calculation. So what this means after all the lifting that we've done, we know that the definite integral from 0 to pi on 6 of x cos 3x dx is the Riemann sum x sine 3x minus 1 on 9 cos 3x evaluated from 0 to pi on 6. So this we can do pretty nicely and pretty quickly. We do some substitution. So this equals 1 on 3 times pi on 6 sine of 3 pi on 6 minus 1 on 9 cos of 3 pi on 6 minus, big bracket, 1 on 3, 0 sine 3 times 0 minus 1 on 9 cosine of 3 times 0, big bracket. Let's go through and cancel and clean up. So let's clean up our fractions first. This guy here becomes pi on 2. This guy here becomes pi on 2. Now cosine of pi on 2 is 0. So this cancels. 0 times anything is 0, so that cancels. Cosine of 0 is 1, so that cosine cancels. So now I do some evaluation. Sine of pi on 2, what's that? Sine of pi on 2 is in fact 1, so that guy cancels 2. So now I can start cleaning up even further. So I get this to be pi on 18. That comes from there. And then minus 1 on 9, which comes from here. Minus 1 on 9? No. Plus 1 on 9. Negative times a negative is a positive. Okay. I hope that was useful. Good luck.